All right, so I'm going to talk about Xcode. We heard a little bit about Xcode from Boris yesterday, and I'm sure everyone is tired today after hearing so many technical talks. But I'm going to do another technical talk. A little less code this time, but still pretty in-depth. So a little bit about me. As we said, my name is Grant Paul. I come originally from the jailbreak community, but now I work at Facebook, and I'm on Twitter at CHPWN. So Xcode. I think Boris asked this yesterday, but I'm going to do it again. How many people in here have used Xcode? Actually, let's rephrase that. How many people in here don't use Xcode? Oh, a few hands, surprising. If you have used Xcode, how many people in here, when they're merging a pull request or putting up a diff, have seen a merge conflict? Good show of hands. I bet that most of you who raised your hands for that didn't really know exactly how to fix it and probably didn't understand exactly what was going on in that project file. All right, another one. Raise your hand if you ever hit a weird error that you didn't understand using Xcode. All right, pretty much everyone. And then when you hit that weird error, you went on Stack Overflow to try and figure out how to fix it. And you found a post by someone who maybe didn't really understand what they were doing, but they put something there that maybe might have worked for them. Pretty common. So I'm going to try and explain enough today that hopefully you won't have to do that quite as much in the future. And maybe when you see those merge conflicts, you'll know how to fix them. But first, I want to talk about what Xcode is, because Xcode's a pretty big app, and there's a lot of stuff in it. And to me, there's sort of three main parts. The first part is Xcode is a text editor. When you type into Xcode, you can use it for Objective-C, Swift, or any other language. And it's a pretty good text editor. For Objective-C and Swift, it has some of the best code completion that you can find. It has inline errors, automatic syntax highlighting. It formats your code really nicely. It's pretty good. I mean, it's not Vim, but it's pretty good. So Xcode's also an IDE. This one doesn't get quite as smiley of a face as the last one, but it's still a pretty good IDE. It has interface builder. You can drag and drop between there and in your code. It has quick look debugging, really integrated with a debugger, better than pretty much anything you can get elsewhere. It occasionally crashes, occasionally has bugs, but it's still a pretty good IDE. The last thing that Xcode is a build system. And Xcode's a pretty bad build system. Unfortunately, the Xcode build system is also one of the most important parts of any app. No matter what you're building, what kind of app it is, the Xcode project file and the build system that parses and uses those Xcode project files controls basically everything about the app. And so I'm going to try and explain that build system. But first, let's talk about build systems in general. When are build systems good, and when are build systems bad? And then I'll also get into how I think Xcode does on those criteria about what makes a good build system. So to me, there's sort of three important parts. First, a build system should be simple. You should sort of be able to know what's going on. It should have features that you can understand. It shouldn't be too complicated. And there shouldn't be anything in there that when you look at how you're trying to build your app, it's not really clear what's going on. So a lot of build systems like Make are really good with this, because you just specify exactly what commands to run, exactly what arguments, etc. to do in your build system. They should also be reliable. If you make a change, it should always have to rebuild. It should always know exactly what to rebuild in order to get the product as specified by the configuration. You should never have to go off and delete files or do a clean build just because you made a change it doesn't understand. And of course, they should be efficient. You shouldn't spend your time waiting for unnecessary steps that the build system is doing. So let's talk about how Xcode does. First up is reliability. These are all the most popular continuous integration services for iOS. If you've used any of them, you've probably seen Xcode flake out at least at one point. And if you've used Xcode locally, you've probably had to go in and delete drive data at some point because it stopped working. That's not a very reliable build system. Next up is all of these features. I would bet that at least one of these features has caused an issue for you in the past if you worked on pretty much any app. And I bet that one in the bottom corner, code signing, is probably been one of the worst. I think it would be a challenge if you want to just go online and try and figure out what one single one of these features actually did, or how to actually understand what they're doing, rather than sort of just finding weird solutions online that try and explain it without really having much information or understanding of what it's doing. And even for all of that with simplicity, that I didn't even mention the Xcode project file format, which is totally not meant for humans and basically impossible to understand unless you spend a lot of time digging into it. So Xcode is not really a very simple build system. And finally, one last point. Xcode has basically no documentation, at least for the build system part. There used to be a document. There was this PDF. It was like 100 pages long. It was on Apple's website. It was called the Xcode Build System Guide. And then Xcode 4 came out, and Apple decided, well, nobody needs to understand anything anymore. And they marked it deprecated and took it down. So now if you want to understand how Xcode works, there's basically nowhere you can turn. All of the new features, things like Swift or WatchKit and watchOS, not documented anywhere, at least in terms of the build system. So in terms of those criteria I mentioned, reliability, simplicity, efficiency, I would give Xcode 0 out of 3. And so because of that, what most projects end up needing is some kind of alternative. At some point, it just becomes too much work to deal with all of the problems and issues that Xcode comes up with. And so one thing that's pretty common nowadays is to start generating Xcode projects. Write them in a simpler language that you might actually be able to understand, and then use that to create the complex format that Xcode wants. So in general, is this something you can do? I would suggest that you probably should do it. There's some drawbacks. For example, if the systems don't map one-to-one with what Xcode wants to do, they can end up with some pretty complex hacks in order to get Xcode to do what they want. But in general, even if it's a little messy into the mapping on Xcode, it's better to avoid having to deal with all the messy project files rather than trying to find something and deal with the project files directly. So the most popular way of generating Xcode projects is, of course, CocoaPods. I bet that many people in here have probably already used CocoaPods, and a good portion of their Xcode projects are probably already being generated from scratch. And the pod spec format is really nice. Unlike with Xcode projects, if you want to understand what something in a pod spec does, the CocoaPods website documents every single property. You don't have to guess. And so CocoaPods is really great for third-party libraries, and you can also use it for internal libraries and parts of your app as well, although that's not quite as well supported and is a little more complex to set up. Unfortunately, you can't use CocoaPods to generate the actual main application target as well, so you still have to maintain at least one Xcode project, which can be a little annoying. Other options are Google's build tool called Bazel and Facebook's called Buck. Both of these are a little different from CocoaPods in the sense that they have their own build systems. They can generate Xcode projects as well, but they can also build the projects without Xcode in the first place. And that makes it a little harder to port your project to these build systems from scratch. For more on this, you can, well, you probably already heard Boris's talk yesterday. But if you can't deal with a project generation, or you can't use it because they don't support some new feature like tvOS or watchOS 2, you end up needing to maintain handwritten Xcode projects anyway. And so I'm going to try, I mean, this is never fun, but I'm going to try and give a few tips that can be useful if you're trying to maintain these yourself to make it a little easier. So the first part is you have to understand all the sort of little pieces that go into the Xcode build system. There's a lot of different pieces here. This pretty complex graph is only a subset. But the one that's the most important is the target. A target in Xcode says, this is something that I want to build. Here's what platform, what SDK I want to build it for. Here are all the files that go into it. And here's the result. And that's sort of the core unit of Xcode's build system. Everything else is either layered on top of that or sort of a subcomponent of the target. So some of the things built on top of it are projects, which are just a collection of targets that all can talk to each other. and schemes, which say these targets should be built in this order or should be built according to their dependencies. And workspaces, which just take project files and put them into the same Xcode document without having to embed all the projects within each other. Inside of a target, the most important thing is build settings. Build settings are also pretty not very well understood because they're not really, well, first, they're not really documented very well, but they're also very complicated. Build settings are specified per configuration, and they're sort of key value pairs that let you say, this compiler warning should be turned on, or these linker flags should be disabled, or other features like that. So when you're dealing with build settings, most of the time what people do is they put you go into the build settings tab in Xcode, and you check off some boxes, or you change some flags, or you add some include paths, or do a bunch of other things. But instead what you can do, and this ends up being a lot more maintainable if it works for your project, is put your build settings in an xconfig file. Of course, like the rest of Xcode, these are totally undocumented, but they do work, and they're pretty easy to set up. And unlike Xcode projects, xconfigs are totally human readable. You can have comments in them, and they can also include other ones, so they can be reusable. And if you look online, people have tons of example xconfig files out there that can make the basics of setting up like a framework or a watchOS static library a lot easier. So related to that is the problem when you have a bunch of different targets for a bunch of different platforms. So now today we have 4 different platforms that you can be writing a framework for. You can go for iOS, watchOS, tvOS, and macOS. And the result of that is that because Xcode targets only support one SDK, you have to have 4 copies of the same thing just to be able to build. And like we heard yesterday, there's a bug in Xcode where they all can't have the same name, or archiving doesn't work when you're trying to release your app. And so in order to maintain this, what ends up happening in a lot of cases is people configure their targets in the Xcode UI. What this means is that each of these duplicated targets for all the different platforms has their own copy of the build settings. And so if you change one build setting to fix some weird Xcode issue in one target, in one platform, it doesn't fix it for all the others. And so that makes it a lot harder to maintain it in the future, as you need to make more changes in order to fix the latest weird Xcode errors that come up. So a better way to do this is to create a single project file that has all of the targets, one for each platform in it, per framework. So in this example, screenshot is from Nacho Soto for their Watch Chess app. What you would do is you would create a single framework for your chess, or a single project for your chess framework. And then you would put each type of the chess framework for iOS, watchOS, tvOS into that project. And then you can use a single xconfig at the project level to define build settings that are common between all of them. And because that's almost all of the build settings, they end up all being defined in one place, so you don't have to deal with updating them in 3 different places whenever you make a change. All right, so next up is the Xcode project file format. And so this is something that basically nobody understands. It's really complicated, it's not human readable, and you have all of these weird numbers in there, these weird identifiers, these weird comments, all of this stuff that's pretty confusing. But if you look into it, it actually becomes pretty simple. You have, inside of the project file, all it really is a serialized graph of all of the different objects that Xcode uses to build your app. And so if you start at the top level, if you look on the right of the slide, you have the actual project object along with its identifier. And each object has references to other objects also defined in the project file, each using the identifier of the other object. In many ways, it's very similar to pointers for objects in memory, except instead of a memory address, you have the unique identifier of the other object also in the file. And so the project object has a pointer that references the target object. It also has many more. It's just a simplified diagram. And then the target object has references to all of the different files that go inside that target. But one thing that can happen, just like in your code, how you can get memory leaks if you forget to clean up an object and it still has references hanging around, you can get the same thing in Xcode projects. If you delete a file, but you forget to remove it from the file system, or a merge conflict ends up leaving it in the Xcode project, you can sort of end up with these zombie files left around in the Xcode project that there's no way to delete. And so what you'll have to do is you'll have to go in manually and look inside the Xcode project and find them and clean up the extra lines that were left around due to the merge conflict or incorrect file deletion. And this can get pretty confusing, and it's one of the reasons that a project generator, which can regenerate the project from scratch, is a good idea. But it can also be very useful in order to get rid of the sort of red items that can sometimes show up in the left column in Xcode, or that show up when you're trying to link libraries into your app. And so generally, the main takeaway from this is that Xcode projects are code just like any other code in your app. And so just like in the same way that you wouldn't accept a pull request without reviewing it and reading through all the code in it, you shouldn't accept a pull request without reading through the Xcode project changes in that diff as well. So the next time you see a pull request and it has like 20 lines of code changes but 500 lines of Xcode project diffs, you should take a look at what's going on in there. Was it, did they accidentally move a target around and cause everything to get rearranged? Did they accidentally add some files? Even if they're not getting referenced, it won't break the build. It's worth treating your Xcode project just the same as code, because the wrong flags in an Xcode project or the wrong files being built into your app, everything might still compile and might seem to work, but it can be just as bad as any kind of bug in your app's actual code. And so next up, I'm going to talk about, once you hit those weird Xcode errors, how you can try and fix them. Things will always go wrong, even if you're looking very closely at your Xcode projects. And especially when new versions of Xcode come out or new SDKs change things, you can often hit weird errors, and you might not have an idea of where to start when looking for how to fix them. So the first place that you should always look is the build log. What you want to do is you go into the left column of Xcode in the far right tab, and you can see the logs from all your builds. And if you go down to the file that crashed, you can click the sort of tall hamburger button, and it'll expand out into the full log of the command that ran to invoke the tool that Xcode was running. So Xcode's build system, it doesn't actually compile anything itself. It just calls out into command line tools that do all the work for it. And unlike Xcode, most of those command line tools are totally documented. And so if you take the command it's running and you pull it out of Xcode and paste it into terminal, you can figure out exactly what went wrong in that command, and you can try editing it and look at the documentation for each of the flags it's passing in order to figure out what to do. Especially for linker errors, this can often be really useful, because you might realize when you pull it out that it's missing the -l flag or the -framework flag for something you really thought should have belonged in there. Or it might not be passing a flag that you would have expected. So after you've done that, the next thing is to take the thing that you figured out that went wrong in terminal. So for example, you might realize you're missing an include path, and you need a -i flag to fix it. And then you need to figure out, well, which Xcode build setting should I modify in order to fix this? And this is a little harder because, like everything else in Xcode, most of these are undocumented. But you can often use context to figure it out. So for example, if you're missing an include path, but you have 3 other include paths that are showing up, you can search for those in the build setting editor and be able to find exactly where you're supposed to add it. And so you can do that for a lot of build settings, and that's often the best way to sort of figure out which ones you need to use to be able to fix what you're trying to find. And so I've been saying this whole time that everything in Xcode's undocumented. That's a little untrue. There is a bit of information on Apple's website. They have an Xcode glossary which lists off all the sort of like parts that go into an Xcode build that can be really useful for getting a basic understanding of what's going on. And that old Xcode build system guide from Xcode 3.2, like 4 years ago, is still pretty relevant. They haven't changed that much since then. The only major new features have been embedding watchOS apps and all of Swift support. And also, as Boris said yesterday, Sam Marshall has by far the best resources for how to understand Xcode. There's a bunch of pages on their website, pewpewthespells.com, that have a ton of useful information about all the different build settings that are mostly undocumented in Apple's documentation. But you can look up there. All of these links will be online in the slides after the talk. And finally, for just a general understanding of the sort of flow that Xcode goes through, especially when building a target, the Objective-C.io article, the build process, by Florian Kugler is really great because it sort of explains each step that goes through it, that Xcode goes through in order to build the app. All right, thank you. And I'm happy to take any questions, even if it's just about your specific weird Xcode error you can't figure out.
Hi, Grant. Great talk. Just a quick question. Do you know what's the error 65?
I don't. But you can always, depending on where it is, you can always look to see if it's in one of Apple's few documentation pages. Or if not, as Adam Bell recently suggested, you can always pull up your Hopper disassembler and start looking.
So for current projects that we have, what's the best way that you'd recommend us to continue going forward? Would it be switching to Buck or Bazel or using some sort of version control system to make sure that we don't screw up our projects and stuff like that? Just going forward as a general rule of thumb?
I think it depends on what kind of project you have. If you have an app that's already heavily using CocoaPods, you might look into using private pod specs and private pod repos in order to make even more of, especially your internal libraries, use CocoaPods as well. If you have a project that's pretty small or you want to just get Xcode out of the equation completely, switching to a totally different build system can be a good idea. And if you're working on a project that's reasonably small and Xcode doesn't have too many issues, it can be fine just to stick with Xcode projects and then just try and keep them as clean and maintainable as you can and avoid just as much complexity as you can.
Hi. Have you looked into creating a Xcode plugin that would replace the build system with Bug, for instance?
I haven't myself. I think it would be pretty hard because Xcode's build system is tied really closely into the UI, essentially. The same project file that says which files to build, which targets to build, how to build each file, is also what says how to lay out the files in the left column of the UI and everything else like that. And so those are so closely tied together that I think replacing the build system within Xcode would be a pretty challenging task and would be even more challenging as more features get added.
You talked a bit about generating a project file instead of making one yourself. Do you worry at all that because the Xcode project format is undocumented and is kind of a hodgepodge of things, do you worry about the maintenance burden of that going forward?
I think that's usually less of an issue. So the current Xcode project format hasn't changed since about Xcode 3.0, which at this point is a number of years old. Don't even know how many. And so it might change in the future, but it seems like it's generally a pretty stable thing that there's occasional extensions for things like watch apps or Swift and stuff like that, but they're generally pretty small relative to the overall format.
Thank you.
All right, thank you.